Hey everyone, Kilo India 5, India Juliet Bravo here. Thought I'd make a quick video on my recent antenna escapades. I have figured out how to put a vertical in my HOA restricted neighborhood, which is something that a lot of ham operators have to deal with, right? But it's not the end of the world. So I already have an end-fed half-wave or random wire antenna strung across my roof that I had made some previous videos about. That works really well. But I wanted to see what a vertical would do, and I have a R7, a Cushcraft R7 that it's not quite in operational condition yet, that I thought about putting up, but that is definitely going to attract the HOA police. It's a massive antenna. I have a couple of high gains. I have a whole bunch of stuff that I could try to use, but it's going to attract a lot of attention. So I was trying to think of something stealthy that wouldn't get me in trouble. And I noticed that there were a lot of those ventilation pipes for the plumbing sticking out of all these houses. And I wondered if I could stick my hamstick in there. And I can. So I designed and 3D printed a little mount for a 3/8 by 24 antenna mount, the stud. And that fits it nice in the pipe. I put it up in the pipe, cut some holes in the PVC. I ran a piece of 75 ohm standard coax from the office up into that pipe, and in fact I didn't have to run it. It was already in the attic, which is great. So I just have a piece of coax sticking out in the office over there. I'll show you in a minute. I hooked up some adapters to that. I ran that to my transceiver, in this case my ICOM 7300. That piece of coax, like I said, was already run when the house was built, which is great. No extra work for me. That goes up in the attic, and that connects to the bottom of the hamstick. So yeah, let's go ahead and take a look in the attic, see how I installed this, and kind of maybe we can try to get on the air and see some results and have some closing thoughts.
All right, so here we are in the attic. So this is a ventilation pipe. It's, I believe, it's 2-inch PVC. As you can see, I've done some modification to it. So first things first, what's in there? I'll pop a picture of the hamstick mounting mechanism or structure that I designed and 3D printed. But essentially, it's some PETG with some ventilation holes, so this thing can still vent. Has a standard 3/8 by 24 stud mount in the center. That goes into a PL259 to coax. I cannot remember the name of the connector, but standard, like TV or internet coax here. And then, that connector, that adapter screws into this piece of coax here. It's 75 ohm coax. It's already pre-run in the house. This goes directly to my office, which is my little kind of ham shack right now. And this whole thing is stuffed up in the tube. And I'll show you a little bit later what the hamstick actually looks like outside the roof, but it's mostly outside the roof, like above it. It's not that obvious though. So these little screws are just to prevent anything from dropping down into the actual vent. This is just a drill bit that I have stuck in there to prevent the whole structure from falling down. And there's also, you can't see it, but there's a screw on the top, on the outside, very small, that prevents, there's like a little adapter that goes over the top of the antenna, and there's an adapter underneath that the antenna screws into. Now the one on top is intended to, just give it more structural stability during wind, load, and such like that. I didn't want that to come out and roll down the roof and have to go find it or make another one. So I put a small screw in the top to hold that in there. I'll show a picture of that as well. So that's the antenna. And I hooked up my nano VNA to that, to the end of the coax down in the office, and I remoted into my computer, and I tuned the antenna up here. That way I didn't have to run back and forth. And that does take into account, the loss from the 75 ohm coax, because that will, change the SWR. It's expecting, the transceivers expect, 50 ohm. Oh, here's some rain. Expect 50 ohm coax or cable, excuse me, 75 ohms. So it'll take, I believe, like a 1-to-1 SWR and take it a 1.5 to 1, which is not a massive deal for HF. Or excuse me, it's not a massive deal in general. That change is for HF. Excuse me, 1.5. Coming from 1-to-1. Now, if you use UHF or VHF, that will change drastically. This has a lot higher loss at UHF, VHF frequencies, but that's a different topic. Okay, so that's the antenna, that's the mount. So radials, right? Radials, it's a vertical. So how did I do radials? Well, I had kind of a crazy idea, and it seems to work. Radiant barrier, right? So the way I see it, the way I understand it, limited understanding, is RF doesn't necessarily travel down the center of the conductor, it travels on the outside, right? It's the skin effect. So I was thinking, ideally you want something kind of thin and large as a radial field, right? So like a massive circular copper disc or something like that. Well, it just so happens we have radiant barrier all throughout this attic, right? It's everywhere. It's a new house, built just a few years ago, excuse me. That's all the way down there, right? It's everywhere. So what I did is I ran 2 pieces of speaker wire, one in each direction, and just stapled it onto the radiant barrier, and then I started putting little pieces of ground strap. And I got my multimeter out, and I know it's not perfect, but it at least shows continuity electrically. So I know it's slightly different, with RF, but I figured that's the best I can do. And so I just went panel to panel, and I checked for continuity, and I went all the way down. So there's pieces like here. You can see I'm going, this is above me. Massive ground strap there because those panels are not connected electrically. Now they are. Same thing here, massive piece, goes across, connects. So for the most part, this is a solid radial field, I suppose you could say. Like I said, just the radiant barrier. This is a problem with hams in newer houses, especially in the South here in Texas. This is part of kind of efficient home building now. So this blocks some signals. Now, I've actually, believe it or not, had good luck with my little J-pole right there for UHF, VHF work. Works just fine for local repeaters through this, but, for HF, it wasn't going to work too well probably. So I decided to put the antenna on the outside. And so far, so good. Now, this antenna system doesn't work much better or worse than my end-fed half-wave that I have draped across the top of the roof on the outside. But it's another option to have, and having antenna options is nice. So the coax comes out of the wall from the attic into these connectors, and the cable comes all the way over into my transceiver next to my Forky. There's a switch back there. One's for the hamstick, one is for my end-fed half-wave, and then into my ICOM 7300. So here you can see this is a screen grab of PSK Reporter for this vertical, the hamstick on my roof. After just 2 hours of transmitting at, I think it was about 10 watts. So that's 10 watts, at the transceiver, so you have losses and everything like that. So I think for what it is, this does pretty well. If you have, limited space and you happen to have an extra hamstick laying around, maybe this is a viable option for you, at least for FT8. I'll try some voice right now, but it's middle of the day, and this is for 20 meters, so it might be kind of hit and miss. But yeah, I think this shows that it does at least work, and you can go and make some far contacts with it, and yeah. So I hope you guys enjoyed the video, and I will post more videos as I make more experiments with antennas. I have a doublet actually I just built
I'll probably post here soon. And yeah, thanks for watching. And 73s.